All right, welcome back. So we're gonna go ahead and finish up this chi-square goodness of fit example. We will cover stat key in class, though you might be able to kind of figure it out on your own from this link. But if you use stat key, you should get a p-value of 0.093, which again we'll talk about in class how to get that. But all that is the area of the shaded area in this curve, which kind of matches our picture-ish. That seems like about 10% of the area under the entire curve. And so remember, we're only getting area on the right tail because we agreed that large chi-square values are evidence of the alternative. And so before, when we had the kind of the normal distribution, we shaded both tails because evidence for the alternative would be on either side of the distribution. But now, since we reasoned on the previous page that the observed counts only would look really different than the expected counts, only if the alternative hypothesis were true, then that would mean that the chi-square would be large, and so only large chi-square would be evidence of our alternative hypothesis. Okay, from here, now it's super similar to what we did with our single proportion examples. And so again, we want to give a statement about our point estimate. And so I'm just going to say we estimate that the proportions of people who prefer Bulbasaur, Charmander, and Squirtle are, and then I just want to go back to my data to grab those sample proportions. So our 13 over 56, 17 over 56, and 26 over 56, respectively. So that's our statement about our point estimate. And now we just want to say how much evidence we have for our alternative hypothesis. And so we want to say that there's weak or marginal evidence, and we want to state what our alternative hypothesis is in context of the problem, so that at least one of the proportions of starter preference is different than a third. So remember, weak or marginal, that comes from our little scale of evidence, and since our p-value is less than 0.1 but bigger than 0.05, this was the adjective that we were going to use. And we want to give our chi-square value 4.75 and our p-value. Okay, so now we kind of want to make a little bit of sense of this conclusion with the data that we actually observed. So that's where these contributions for the chi-square stat are going to come into play. We've actually already computed these back on page 12 in this step. The contribution to the chi-square stat for Bulbasaur is 1.72. For Charmander, it's 0.149. And for Squirtle, it's 2.8778. All these are the observed minus expected squared divided by the expected for each kind of individual category that we got. And so you could see that in terms of the three categories that we have, Squirtle is the one that's contributing the most. You could see this from our data because Squirtle's is the farthest observed count from what would be expected if the null hypothesis were true, so the 18.67. Squirtle's is the farthest away from that, so he's giving the most evidence for the alternative hypothesis of the three. So we can just say something like Squirtle's observed count is farthest from what would be expected if there is no preference. Therefore, Squirtle has the highest contribution to the chi-square stat. Bulbasaur's is the second farthest, so he has the second highest contribution. Charmander's 17. That's super close to what's expected if the null hypothesis were true. So he barely has any contribution to this chi-square stat at all. So just to kind of wrap up, there was an actual survey that did this, and the results kind of match what we came up with, except in their survey, most people preferred Charmander over Squirtle, and Bulbasaur had the least. And so you could, if you wanted to, practice with this data and check to make sure that you end up with the appropriate p-value as a little bit of extra practice. As always, kind of let me know if you have any questions. Where we're moving on from here is we're going to start looking at the association between two categorical variables. And so we're moving away from just looking at one single categorical variable like Pokemon preference or answering a question correctly, and starting to look at whether we have evidence for some different types of associations that we explored with stuff like those contingency 2x2 tables and those side-by-side bar charts.